here we are, 9-5, day 2. Some more shortcuts to the reduction formula. Okay, this next shortcut works for even powers of secant and cosecant. And this one is exactly like the even powers of, or excuse me, the odd powers of sine and cosine that we just finished, where the trick is to first put a secant squared or cosecant squared with the dx, because each one of these would be the inside derivative, so that would be the power rule. So you steal an x squared or a cosecant squared, whichever one has the even power, put it next to the dx. Then write the remaining even power as a power of 2. Use a Pythagorean identity, substitution. Expand with Pascal's triangle if need be. Then you do the distributing and then the power rule integration. So then distribute. And use power rule. Okay, let's try one. The integral of cosecant to the 6th x times cotangent x dx. Okay, I've got the even power on cosecant, so that's the one where I'm going to steal a cosecant squared, slide it next to the dx. So that will leave cosecant to the 4th times the cotangent, cotangent x, and then the cosecant squared that I'm stealing. I know it's going to get thrown away, so I'm going to stick it there. Rewriting this, the remaining even power, as a power of 2. So that's cosecant squared x squared. Then I have my cotangent x, cosecant squared x. Pythagorean substitution with a cosecant squared. Let's see. Here's cosecant squared. Solving, so that equals cotangent squared plus 1. It's already solved for me. So cotangent squared plus 1. So cotangent squared x plus 1 squared. Still have this cotangent. Cosecant squared. Okay, squaring using Pascal's triangle, I know it's going to have the 3 terms. Still have this hanging on the end. Cotangent, cosecant squared. Okay, I've got the coefficients of 1, 2, 1. This time my first term is the trig function. So here I'm going to start at the beginning with cotangent squared squared, cotangent squared to the first, then nothing. My end term is a 1, so it's just 1 cubed, 1 squared, 1, not necessary. Now I'm ready to distribute and have 3 separate integrals. So taking this whole chunk, distributing. Okay, first thing I'm going to do is square this. That's cotangent to the fourth times the cotangent out here gives me cotangent to the fifth. I'll write it like this with the cosecant squared. The next one, the cotangent squared is to the first times the cotangent here. It's going to give me plus 2 times the integral of cotangent cubed. I'm going to write it like this, and then I have my cosecant squared. And then my last one is just this times by 1 cotangent times cosecant squared x dx. Okay, now before I do power rule, I want to make sure that I've got the derivative of the inside over here. I can't do power rule because this is the rule I'm following, remember? I think you remember this. You have an inside to a power. As long as the u prime is over here, you do the add 1 and multiply by the reciprocal business. So, cotangent's derivative is a negative cosecant squared u prime. Well, all I'm missing, I've got the cosecant squared, I'm just missing the negative. So I need the negative 1. So I need the negative 1. So negative, adding 1 to that, the reciprocal is going to be 1/6. Cotangent to the 6th. Moving on to this one, same thing, the inside derivative needs a negative. So I'm going to make that a negative. That'll become a 4, so 1/4. That'll go down to 1/2. And then the last one here, this is still a power rule. You can think of it as cotangent to the first. Inside derivative is a negative, so I need a negative. And I'll add 1 here, make it a 2, so I need a 1/2. So minus 1/2 cotangent squared. And this can come down to a 1/2. And there it is. Oh, are you kidding? Oh. Well, I'm different. Okay, let me check. Where did I make my mistake at? Maybe it was on here. That one's good. 2 cotangent squared. Maybe I didn't have that. Oh yeah, the mistake was, okay, I'm good. I had a mistake in my notes. I actually used it right. Okay, moving on to the next one. Try one more of these. Integral of secant to the fourth 2x times tan cubed 2x. Okay, even powers of secant and cosecant. And again, it's going to be paired up with tangent because one's the derivative of the other. So, I'm going to steal a secant squared. That will leave a secant squared 2x. Tan cubed 2x. And another secant squared 2x here next to the dx. This is the one I changed, so this is the one I'm going to substitute with the Pythagorean theorem. Secant squared equals 1 plus tan squared. 1 plus tan squared 2x. I don't need a power out here because it was just secant squared, and this is secant squared, times tan cubed 2x, secant squared 2x. Okay, I don't have to expand with Pascal's triangle because the power is 1, so I'm ready to just take this whole chunk and distribute it twice. So my first integral this whole thing gets multiplied by 1, so I've got the tan of 2x cubed with the secant squared, 2x, 2x, hanging out with the dx, plus, now distributing, my tans are going to combine. Tan squared times the tan cubed is going to give me tan to the 5th. 2x, secant squared 2x, dx. Oh, I'll write it as a, I'm going to go that way so I can see it. Okay, now before I do power rule, I have to make sure I've got the derivative of the inside attached to the dx in order to do power rule. So tangent's derivative is just secant squared times the derivative of the angle. Okay, so I've got the secant squared 2x. I need the derivative of the angle, which is a 2. So I got to multiply this by 2. So I got to do a 1/2. And now it's ready for power rule. So I keep the 1/2. That's going to go to a 4, so I'm going to need a 1/4. Plus, again, same derivative of the inside. The derivative needs a 2 next to the secant squared, so I need another 1/2 out here. So 1/2. Power rule is going to make that a 6, so I need a 1/6. Tan to the 6, 2x, plus c, so it's 1/8. Tan to the 4th, 2x, plus 1/12. Tan to the 6th, 2x. Okay, 1 second.